Hi everyone, this is M. Srihari, the student of Emertxe Institute of Technology and Sciences, Kadapa. Today I am here to give you a presentation on home automation using IoT. First of all, I am thankful for the Emertxe Information Technologies for giving us opportunity of doing this internship program. And I am also thankful for our project guide Jayalakshmi ma'am for guiding us to do this project. This project was done by me and my friend Kottapalli Balaji. In this presentation, we are going to discuss about the following contents. What are the topics that was covered during this internship? What is meant by IoT and embedded systems? What are the requirements needed? What are the peripherals and the components required for this project? And how the garden lights will be controlled? And how the water level in the cereal tank will be controlled through the mobile phone using IoT, and what are the simulation images, and conclusion. Going to the next slide. Topics covered during internship. During this internship program, we had learnt about a lot of topics about C program, C++ programming, and IoT. In C programming, we had learnt about keywords, data types, operators, conditional statements, arrays, and pointers and functions, etc. In C++ programming, we had mainly learnt about OOPS concepts, which includes inheritance, encapsulation, and many other. Coming to the IoT, we had learnt about IoT architecture, what is meant by embedded systems, different types of embedded systems, and what are the components required for embedded systems, LED, Arduino Uno board, etc. Going to the next slide, we are going to discuss about what is IoT. IoT stands for Internet of Things. It refers to the network of connected devices using Internet that facilitate communication using sensor signals and actuators. The Internet of Things is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or external environment. The Internet of Things describes the network of physical objects, that are things, which are embedded with the sensors, softwares, and other technologies for the purpose of exchanging of data with their devices and the systems through the internet. Going to the next slide, we are going to discuss about embedded systems. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems may also function within a larger system. The systems can be programmable or have a fixed functionality. Industrial missions, consumer electronics, agriculture, and processing industry devices, automobiles are the possible locations for the embedded system. In the next slide, we are going to see what are the requirements needed, both hardware requirements and software requirements. Hardware requirements. In hardware requirements, we need Arduino Uno, ETH-W5500, PCF8574, temperature sensors, LCD, LDR sensors, LED. Coming to the software requirements, we need Arduino IDE software and PiximLab software and Blink IoT app for the controlling through the mobile. Now, let us see the peripherals required for this project. Peripheral means the components that which are required. The mainly three components are required for this project. Those are LER sensor, temperature system, and serial tank. LER sensor. LER sensor is used to read the sensor values based on the variation in the light. Temperature system. It consists of heater and cooler. We can read the temperature from the temperature sensor, that is LM35 sensor. Serial tank. We can read the volume of water in the tank through serial communication. Now going to the next slide, we are going to discuss about Arduino Uno board. Arduino Uno is a new technology which is based on the 80 mega 328p microcontroller. It is easy to use compared to other boards such as the Arduino Mega board, etc. The board consists of digital and analog input or output pins and other circuits. The Arduino Uno includes 6 analog pins that are ranging from A0 to A5 and 14 digital pins that are ranging from 0 to 13. These digital pins are also includes 6 types of pulse width modulation pins which are indicated with the negative sign. This board also contains USB connector, a power jack and an ICSP. ICSP stands for In-Circuit Serial Programming header. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. Let us see what is ETH W5500. The W5500 chip is a hardware TCP or IP embedded Ethernet controller that provides easier internet connection to embedded system. The W5500 sensor enables user to have the internet connectivity in their application just by using the single chip in the TCP or IP stack. It also supports power down mode and wake on LAN over UDP and also high-speed serial peripheral interface. Going to the next slide, let us see what is PCF 8574. PCF 8574, it is a silicon CMOS circuit. It provides general purpose remote input-output expansion for most microcontroller families via the 2-line bidirectional bus. The device consists of an 8-bit quasi-bidirectional port and an 12C bus interface. The corresponding picture was shown in the slide at the left. Let us see what is temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. The temperature sensor consists mainly 3 pins. Those are V input, V output, and ground as shown in the figure. In the next slide, we are going to see about LCD HD 44780 sensor. It is a dot matrix liquid crystal display controller and driver LSI displays alphanumeric and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microcontroller. The corresponding figure was shown at the right side in the slide. Let us see what is LDR sensor. An LDR is a component that has a variable resistance that changes with the light intensity that falls upon it. This allows them to be used in the light sensing circuits. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, it exhibits the photoconductivity. Now let us see how the garden lights will be controlled using the Arduino Uno board. The properties of LDR sensors are applied to accomplish the controlling of garden lights. During the day, the outdoor light is so maximum so that the LDR sensor detects the maximum light and the garden light is turned off. Whereas at the night time, the outdoor light is too low, so the LDR sensor detects the minimum light and it turns on the garden lights. Let us see how the water inlet and outlet valve will be controlled. In the home automation project, to control the water inlet and outlet in the serial tank, we need to read the volume of water in the tank through the serial communication and display the CLCD and also display on the Blink IoT app. The main feature is that as soon as the tank is full, the inlet valve is turned off and when the water level in the tank is below 2000 liters, the inlet valve is turned on automatically, and the notification for the same is provided on the terminal of Blink IoT app. Let us see what are the simulation images that are related to this project. As you can see, at the left side we have one image. In that image, at the top left corner, we have LDR sensor. Here we can increase the light intensity by using this button as shown here. And in between we have a monitor. In this monitor we are able to see the temperature and water level readings. After that we have a fan. Which represents the cooler which is used to cool the temperature. And after that we have a white box image which indicates the level of water in the cereal tank. A clear picture of the monitor was displayed at the right side of the slide. In that slide we can see that the temperature value is 30.30 and water level is V is equals to 02. Going to the next slide, we have two figures. These figures are related to the Blink IoT app. The first figure indicates the button widgets for the inlet and outlet valve control. Using these buttons, we can also manually control the water level in the cereal tank. After that, the second figure indicates the button widgets to control the heater and the cooler, which is used to control the temperature of the room. Conclusion. The project successfully demonstrates the applications of IoT technology in the field of home automation, allowing users to control and monitor their homes remotely. The project uses a combination of hardware and software components including sensors, actuators, microcontrollers, and the Blink IoT application to provide a comprehensive home automation solution. Overall, the project demonstrates the practical applications of IoT technology and its potential to revolutionize the way we interact with the environment and devices. This is about the presentation, and thank you. The next part will be continued by my friend Balaji about the implementation of the program and the project. Thank you.
Implementation of home automation using Blink to control the brightness of LED, monitor the temperature, monitoring water level in the tank by using Blink app. The devices required for home automation such as Arduino UNO, temperature system, LED, LDR module, serial tank, Blink out and Blink app. Here, template ID, device name and author token are provided by the Blink Cloud, which is used to interfacing the Arduino board by controlling by the Blink IoT in the mobile app. Here we include libraries from the Blink such as SPI.h, Ethernet.h, Blink Simple Ethernet.h. For displaying the information and notification, we use libraries such as y.h, liquid crystal. Liquid crystal is used to set the LCD address to 0x27 for a 16 chars and 2-line display. This function is called every time the virtual pin 0 state changes to turn on and off cooler based virtual pin value by using Blink write to read the values of the virtual pin connected to cooler. If cooler switch is true, then cooler is on and displayed in the cooler is on. Otherwise, cooler control off and displayed a notification in the CLCD cooler is off. In the same way, heater will be work on. To turn on or off inlet valve based on virtual pin. For writing the inlet valve, to read the values of the inlet valve by using inlet switch. For if inlet switch is true, we are enabling the inlet and printing in the CLCD, that is inflow is on. Otherwise, disable the inlet, that will be printed in the CLCD. Its inflow is off. In the same way, outlet will be work on. To display temperature and water volume as a gauge on the blink app, by using the update temperature reading function, you can send any value at a time. Please don't send more than 10 values per second. For that purpose, blink visual write is used for reading the temperature and reading the volume of the water. To turn off the heater if the temperature rises above 35 degrees, by using handle temperature function. Read temperature and compare with 35 degrees and also check if heater is on. If read temperature greater than 35 and heater switch is true, then turn off the heater. If to print heater status on the dashboard, by using set cursor on LCD print. To print the notification on the blink app, by using visual bright blink terminal V pin. Temperature is about 35 degrees Celsius when we turning off the heater. To control water volume about 2000 liters, for that one we use handle tank function. To check if the volume of water is less than 2000 liters and inlet value is off, and enable an inlet value. For that we enable inlet value function call. We can call the enable inlet value. To print notification same as heater control. If the tank is full and inlet value is on, and turn off the inlet value, for that one we can call disable inlet function. In void setup, we initialize the CLCD to configure the garden lights as input. For that purpose, initializing the LDR, black light, backlight, clear, home, set cursor. To connect Arduino to the blink load, for that one blink.begin auth is used. To initialize temperature system, init temperature system function is used. To update temperature to blink app for every 5 seconds, for that one timer dot set interval 500L update temperature reading. In while loop, blink dot run, keep timer running, that one timer dot run. To control the brightness of the LED, for that one we calling the brightness control function. To read temperature and display on the CLCD, for that one we can read the temperature. We can typecast that read temperature function, because in read temperature we can read integer values. We can't display integer values in CLCD. That purpose we can use typecasting to string. To read the volume of water and it and display on the LCD, for that one we use set cursor on LCD dot print, and we call handle tank and handle temp. In LDR, we initialize the LDR. For that garden light as output. We can control the brightness of the LED. To read the values from the LDR sensor connected to A0 pin. For that one we read analog. Analog read is a function for reading the analog values. Mapping to 0 to 1023 greater than 255 to 0. Scaling down to 0 to 1023 to 255 to 0. In LDR.h, we define LDR sensor to pin A1, garden lights to pin A3, and we call function init LDR brightness control. In main.h, we use for on 1, off 0. Temperature gauge pin can be connected to V1, cooler pin connected to V0, heater pin connected to V2, water valve gauge connected to V3, inlet pin V4, outlet V pin V5, blink terminal V6, and then serial tank. First of all, we initialize the serial tank. To begin the serial communication between serial tank and Arduino board, we go through serial begin and serial write for synchronization communication. Volume function to read the volume of water, combining the higher byte and lower byte. For that one, volume value to return the volume of the value. For that one, return volume value. Enabling the inlet. For that, we are enabling the inlet value and disable the inlet. The serial dot write inlet value disable. In the same way, outlet will be worked. In serial tank.h, inlet value for reading the input digital. For that one, we use inlet value and outlet value. For reading the sensor digital, we use high float and low float. For analog sensors, we use enable and disable. Then we initialize the serial tank and enable inlet, enable outlet, disable inlet, disable outlet, volume. And next, we initialize the temperature system to configure heater and cooler pin as output. That purpose we use pin mode, heater output, cooler output. To turn off the heater and cooler, digital write heater low. That means if the heater is off. For reading the temperature, to read the analog values and converting into voltage and then to voltage into temperature in degrees Celsius. For functioning to control the cooler, we define the function cooler control for controlling the cooler. In the same way for heater also. In temperature.h, heater pin will be connected to 5, cooler pin to 4, temperature sensor is connected to pin A0 and initialize read temperature, any temperature system, cooler control and heater control. And next we move to SimLab implementation of home automation peripherals. Refers to devices that are used to control the automate various systems and applications within the home. In this LDR sensor, LDR stands for light dependent resistor. It is a sensor that changes its resistance based on the amount of light is exposed to. LDR sensor commonly used in home automation to detect ambient light levels and adjust lighting accordingly. Next, temperature sensor. A temperature sensor is a device that measures the temperature of its surroundings. These sensors can be used to monitor the temperature of a room, the temperature of a liquid, or the sensors are often to control heating and cooling systems or to trigger alerts when temperature falls outside of a certain range. And next, CLCD. CLCD stands for Character Liquid Crystal Display. It is a type of display that can show text and simple graphics. CLCD displays are commonly used in home automation to display information such as current temperature, status of a smart lock, or the time. Next, Ethernet. Ethernet is a type of wired network technology. Ethernet allows devices to communicate with each other over a local network, enabling remote control and monitoring of home automation peripherals. Next, LED. LED stands for light emitting diode. LED are commonly used in home automation system to indicate the status of various devices. In LDR sensor, if the sunlight is high, it automatically turn off the garden lights. Otherwise, if the sunlight is more, it turn off the garden lights. Turn on the garden lights. And next, wait few more seconds. We are seen in the tab 1, we have cooler switch, heater switch and temperature gauge and notification. In tab 2, we have inlet value and outlet value, notification and volume gauge. In tab 1, first we on the cooler switch. We observe that we are rotating here. We turn it off, stop it displays in the CLCD. If heater is on, it rises the temperature. Here see in the gauge, temperature gauge. If temperature is about 35 degrees Celsius, turn on the heater automatically. If we on the cooler, it decreases the temperature and it displays in CLCD. When it reaches to room temperature, automatically it switch off the cooler switch. Then we move to tab 2, inlet valve. Okay. We on outlet value, we observe that we decrease the volume of the water. If it reaches below 2000, then outlet value is on. We see volume of water is less than 2000 liters, turning on the inlet value. If the tank is full, automatically inlet valve is off. That will be shown in the notification bar. If outlet is on. Okay. Tank is full, turning up the inlet value.